Today, students, we are going to learn how to solve two-step mole problems. We have done many problems in class where we have been given, for example, a mass of a substance and asked to find how many moles of substance that we have. Or we have had problems where we've been given the moles, number of moles of a substance, and we're asked to find how many particles there are in that many moles. But we haven't done problems where we were given, for example, a mass of a gas and asked to determine the volume. It turns out you need to do those types of problems in two steps. And the reason for that is that everything must first be converted to moles before you can proceed to another part of another arm of this Y. So it would be very handy, students, if you had your Y diagram and a calculator and a sheet of paper in front of you to work some of these problems. You need to turn in your video notes and the answer to the final problem uh, tomorrow in class. So please pause the video at this point to make sure you have all the materials you need. All right, let's move ahead to the next slide. Here's our first problem. What volume would 12.7 grams of nitrogen gas occupy at STP? So we have been given a number of grams of nitrogen, and we need to find what the volume is in liters. We cannot go directly from mass to liters. First, we need to convert this mass into moles. And then from moles, we can convert that into liters. So this is a two-step problem. How would we set up this problem? Well, we would begin with our 12.7 grams of nitrogen, N2. And we know that at the end, we want a final answer in a certain number of liters. We don't know how many liters yet of nitrogen gas. Okay, now in order to go from grams to liters, as I said a moment ago, we need to first convert from mass to moles. In order to do that, we're going to need to use a conversion factor that's the molar mass. So we want to end up in moles, so we put moles in the numerator, and we need to eliminate our grams, so we want grams in the denominator so that grams of nitrogen gas cancel out. Okay, in order to do this, we have to determine the molar mass of nitrogen. If we look at our periodic table, we will see that nitrogen, the element nitrogen, has a molar mass of 14.01 grams per mole. Sorry about that. 14.01 grams per mole. And we have two of these in N2, so we need to multiply that by 2, and our answer to that part of the problem is 28.2 grams per mole. We're going to take the reciprocal of that to work in our problem because we're converting from mass into moles. So we want 1 mole nitrogen gas in the numerator divided by 28.02 grams of nitrogen in the denominator. Now you'll notice that our grams of nitrogen gas will cancel out and we're left in units of moles. We need to convert these moles now into liters. And we know that at STP, and let's just review for a moment, what does STP mean? STP is standard temperature and pressure. And we know that standard temperature is a chilly 0 degrees Celsius. And standard pressure is at the pressure at sea level, which is considered to be 1 atm, 1 atmosphere of pressure. Okay, I'm going to get rid of this portion. That's a review. Have more room to write. So we know that a mole of gas occupies 22.4 liters at STP. We need to have our final answer in liters, so we will put liters in the numerator and moles in the denominator, moles of N2. We need that to cancel out as well, so now it will. And we know that 1 mole occupies 22.4 liters. So once again, our moles of N2 cancel out. We're left in units of liters, which is what we want our final answer to be in. If we do our calculations on the calculator, we should get an answer of 10.1527, and maybe a few more digits in that calculator. But we need to take a look at this point at how many significant figures we want our answer to be in. Our original mass of nitrogen gas had 3 significant figures. So the other numbers used in this calculation are all conversion factors, so they are not considered in determining the number of significant figures. So we know that we need 3 sig figs for our final answer. So coming back to our answer, we know we are going to keep these 3 digits. There's a 5 there. We're going to round off then to 10.2 liters of nitrogen gas, and that would be our final answer. Let's go to the next problem. Next problem states how much mass would 7.21 times 10 to the 25th atoms of iron, that's Fe, have? Now, we are starting off this problem with the number of atoms. And we're supposed to find how much mass this would contain. We cannot get there directly. We need first to convert from atoms to moles, then from moles to mass. So once again, this is a two-step problem. All right, so in this problem, we are starting out with 7.21 times 10 to the 25th atoms of iron, Fe. And we need our final answer in grams because that would be the unit of mass. We don't know how many grams yet. In order to convert from particles to moles, we need to use Avogadro's constant. So we will multiply this. We want moles, our answer in moles, so we put moles in our numerator, and then divide that by 6.02 times 10 to the 23rd atoms in each mole. Right. Now you will immediately see that atoms of iron are going to cancel out, and we're left in moles. Now we're here in this part of the problem. We need to get to mass. We need to do this step. In order to do that step, we're going to have to employ the molar mass of iron. If we look at the periodic table, we will see that iron has a molar mass of 55.85 grams per mole. So for every mole, every 1 mole, we'll have a mass of 55.85 grams. So let's put mole of Fe here and grams of Fe. Now, once again, we see that moles of iron will cancel out. And so the operations that need to be done for this problem are to take our initial number of atoms, divide by the Avogadro's number, and then multiply by the molar mass. So let's do that on our calculator, and if you do that, you should get an answer of 6,689.012, probably some more digits on your calculator. And at this point, we'll need to look at the number of significant figures we need in our answer. Our initial measurement of atoms contained 3 significant figures, so our final answer today also needs to contain three significant figures. So we will want to keep these three digits in the places that they are located. The digit next to the 8 is a 9, so we need to round up. So our final answer is 6,690 with no decimal point brought down. And this number will have three significant figures. That 0 is not significant. And our answer is in grams of Fe. So here, ladies and gentlemen, is the final answer you should get. Let's move on to the last problem. In this problem, we have 99.82 liters of helium gas. We want to know how many atoms of helium would we have? And this problem is telling us that our liters are at STP, so we know that they would contain, each mole would be contained in 22.4 liters. Obviously, we have more than a mole here, don't we? In order to answer that question, we're trying to go from a volume to a number of atoms, but we cannot do that directly. We first have to go from volume to the number of moles. And once we get the number of moles, we can calculate the number of particles. So again, this is a two-step problem. So how would we set this up? We are beginning with 99.82 liters of HE gas, and we need first to convert that into moles. So we need to use the molar volume. At this point, we want our answer in moles, so we put moles in the numerator. We want to cancel out liters of helium, so we put liters in the denominator, and that's 22.4 liters. Then we immediately can see that we can cancel out liters of helium, and we're left with moles of helium. How do we get from moles to number of particles? We will need to use Avogadro's number. So we will put 1 mole of helium in the denominator, because that's the units we want to cancel out. We want to put atoms of helium in the numerator, and we need to put 6.02 times 10 to the 23rd atoms in that numerator. So again, students, you see that moles of helium cancel out. We're left with units of atoms of helium, which is exactly what the problem asks us to find. The calculations that we need to do then are to take our initial liters, divide by 22.4, then multiply by Avogadro's constant. If you do that on your calculator, you should arrive at an answer of 2.682266, possibly a few more digits, E24. You see that little 24 over on the right-hand side of your display, and you know that's going to be the exponent of the 10. Ask yourself, how many significant figures do I need to have in this answer? And you'll look back to the original measurement, which had 4 significant figures. So we are going to round off to 4 significant figures. Notice the 6 after the 2 here, which means that we have to round up that 2 in the thousandths place. So our final answer is 2.683 times 10, get rid of that arrow at this point, times 10 to the 24th. And our units are atoms of helium, He. This, ladies and gentlemen, is your final answer. Now, hopefully you've been able to follow the logic behind doing these two-step problems. I want you to try this problem on your own for homework and bring this in with your notes tomorrow. So please take a moment to copy this down, and then good luck solving it.